Northerly Arrabis, and for today's session, I'll be going to discuss about the discriminants and the nature of the roots of a quadratic equation.
The discriminant and the nature of the roots of a quadratic equation.
Let's recall that a quadratic equation is in the form of ax squared plus bx plus c is equals to 0, where a, b, and c are real numbers and a shouldn't be equal to 0.
In finding the roots of this quadratic equation, we have the quadratic formula x is equals to negative b plus and minus square root of b squared minus 4ac all over 2a, where b squared minus 4ac is called the discriminant of the quadratic equation. Depending on the discriminant, the nature of the roots of a given quadratic equation is said to be real and distinct, or it has two real roots if the discriminant b squared minus 4ac is greater than 0.
For example, given the equation w squared plus 10w plus 21 is equals to 0. To determine the nature of the roots, we must find the discriminant, which is defined to be b squared minus 4ac. But before that, we must identify the values of a, b, and c, which is a is equals 1, b is equals to 10, and c is equals to 21.
Use these values to substitute from the given formula b squared minus 4ac. So we have 10 squared minus 4, a which is 1, and c which is 21. So 10 squared is 100, minus 4 times 1 is 4, times 21 which is 84, so minus 84. 100 minus 84 is 16. Now we have b squared minus 4ac is greater than 0. Thus, we can conclude that this equation has two real roots. Now, if the discriminant b squared minus 4ac is equals to 0, the quadratic equation is said to have real and equal, or has a one real root.
For example, given the equation x squared plus 4x plus 4 is equals to 0. Again, we have to use the discriminant formula, which is defined to be b squared minus 4ac, and the values of a is 1, b is 4, and c is also 4. Now substitute these values to the equation b squared minus 4ac. So we have here 4 squared minus 4, a which is 1, c which is 4. Now simplify. 4 squared is 16. Then 4 times 4 is also 16. 16 minus 16 is equals to 0. So b squared minus 4ac is equal to 0. And we can conclude that since b squared minus 4ac is 0, that this given equation has a distinct root, or has one real root.
Now, if the discriminant is less than 0, the equation is said to have an imaginary root or has no real roots.
For example, given the equation 3y squared minus y plus 7 is equals to 0. To determine the nature of the roots of this given equation, we must use the discriminant formula b squared minus 4ac. Now our value of a here is 3, b is equals to negative 1, and C, which is equals to 7. Now, substituting these values in the
have
formula, negative 1 squared minus 4 times 3 times C is 7. So, simplifying, we have 1 minus 4 times 3 is 12 times 7, we have 84. 1 minus 84 is negative 83. Thus, b squared minus 4ac is less than 0. Now, we can conclude that this given equation has an imaginary root or has no real root.
That would be all, and thank you for watching.